Oh, hello. I didn't see you come in. Welcome to my home and welcome to the online version of Contending Perspectives in Economics. I'm your host today, John Harvey. You may know me from such things as teaching you twice a week. I'm going to do my best here to try to give you the same sort of education we'd be giving you if you were on the Horned Frog campus, winners today by one in a glorious football game that made us all very sick until the last few moments. And I will be trying to stay as close as I can to this microphone because in my testing of this whole process I discovered that you can't hear me very well at all once I move only a few inches away. So, when I left you last, we had finished, don't know if you can see this or not, the labor market graph stuff, where it showed that see what time it is? Start. Okay. I don't want to take more than your usual 75 minutes. Where I showed you the classical view of how the labor market worked, which didn't work very well in explaining the Great Depression. Then Keynes's view that said that, well, what the problem is that it's in equilibrium even when we're at less than full employment. And then the neoclassical Keynesian view, which says, oh, I see what you're saying, Keynes. You're just saying we have sticky wages, which of course Keynes was not. Then after that, we did this study question, number 65. There it is. And this is the one with the explain the following characteristics, fundamental uncertainty, history matters, and so on. All right. And then when I left you last on Thursday, I said that the next question was going to be about the post-Keynesian / Keynes version of how savings equals investment. All right. Now, let me see if I have enough room here to do this. Okay, this is going to be, it's really hard when you're looking at the other way in the monitor. All right, so I won't look there at all. This is savings, all right, and this is investment. And in the neoclassical view, they have to come to equality because if ever investment were to fall, then if I'm the banking system, I'm like, oh crap, I'm paying this much money, I'm paying interest on this much cash, but I'm only getting interest on this much cash. So what do? I lower interest rates until they're equal again. And in the process of equalizing, this is spending going back up, and this is spending going back up because it's savings going down. And so we end up still at full employment level of spending, no problem. Now, clearly Keynes isn't going to come to that same conclusion. He's going to say that something bad is going to happen. And that's going to be study question number 66. Ta-da! Now, before I start that, I want to remind you of some things that we had covered on whatever that other number study question was, and we did the neoclassical version there of 31. So I want to remind you some things there in terms of savings equal to investment. And I'm going to hope that this board back here doesn't fall down because it's merely resting up against this window. Oh, this is Melanie's lovely office here. Here, I'll show you around. These wonderful Four Freedoms paintings from Norman Rockwell from World War II. Big bookshelves. More big bookshelves. Let's see. That's a mirror. Her karaoke machine, which is broken. Very upsetting. Let's see. Some bookshelves and other stuff. So, now let's see. I wish I had shown you my office instead because it has really cool stuff like tanks and airplanes in it. But this is a better place to try to do this taping. All right. So I just sort of have this sitting up here. Hopefully it won't fall down. All right. Remember this. And by the way, let's see. Can you see that? I think so. It would be best if you took notes just like you would in class because that way you'll learn a lot better. Okay. Let me write that a little thicker. Now, the Y, of course, is income or output or expenditure because in a closed system it all has to be the exact same thing because every time you spend money, it becomes somebody else's income, and every time you get income, it's because somebody else spent money. And likewise, you must have spent it for something, so then the value of the output must be the same as well. I'm going to pick up the little microphone thing. Now, up here, let's see. Y equals C plus I. Think of Y up here as income. So, I'm sorry, I did it backwards. Well, let's go ahead and do the income. Think of y here as income. You can only do two things with income. You can consume or you can save. All right, that's it. Now, think of it up here as spending. There's only two kinds of spending in this system. There's either consumption or investment. And, just like in the neoclassical version, it must therefore be true that savings equals investment, because if y equals c plus I, I'm looking at the monitor there where I can see the board, y equals c plus I and y equals c plus s, then it must be true that s equals I. Okay, so that's kind of old news right there, right? All right, Keynes is going to say that, yeah, that's right, they have to be equal, but it's a different process by which they come to equality. And here's how it works in his. Notice I don't have to spray the board with water every time to make it erase like we do in the classroom. Okay, the first thing I need to show you is the consumption function. And you might say, consumption function, what's your function? That's a little schoolhouse rock humor there. If you don't get it, that's okay. Okay. I have C on the vertical axis. Let me see if I can get to where my head's not in the way. I have C on the vertical axis and Y on the horizontal. And this graph is supposed to be explaining consumption behavior. And the basic idea is that the more income you have, which is there, the more you'll spend, which is here. And so it's going to be some sort of positively sloped line. As income goes up, then consumption goes up. Now, how much are you going to spend if you have zero income? Zero. So there's the first point. So it comes out of the origin. Then, at first, let's say the two axes are measured in the same proportion, so that in the same units, so that at first you get a 45-degree line, because if you're at a really low level of income, you basically have to spend everything just to get by. But at some point, you're going to save, because you want to save. And it'll kind of flatten out like that. So that looks kind of curvy there, sorry. It's sort of trying to start off at 45 degrees and then level off a little bit as you go up there. Because the more income you earn, the larger the percentage of that income that you save. And that is the consumption function. I don't know if you can see that or not. It says C equals a function of Y. And let me just get a little more technical here. A plus sign for the fact that the relationship is positive, but you could sort of see that on the graph. All right. Now, we need to make an equation out of that we can use here to talk about GDP, but it's really hard to make an equation out of that line. So, let's do this. I apologize for my horribly unstraight lines. I put a green line right there that sort of matches the slope of the very end and extended it all the way to the vertical axis, all right? And that's as good as, that represents consumption behavior so long as GDP is above y sub 0, then that's as good as the purple line. Because if we're only dealing with levels of income above y sub 0, then that really straight portion at the end represents how much more people spend as they earn more income. Now, why did I bother to do that? Because it's easy to draw an equation of the green line. It's really difficult to draw an equation of the purple line. And so again, what we're going to assume here is we're dealing with an economy that must be bigger than y sub 0. Something larger than that, all right? Now, let's see. I guess I'll continue doing this in green. Let me shift this a bit and see if I can get a little closer to the yeah, it's a little better. Okay. My head may be out of the shot, but then that might be a plus for everyone. Now, okay, so say that the vertical intercept is A, all right, and that the slope of the line is B. Now we can write a very specific equation of that line. C is equal to A plus B times Y, all right? So consumption is equal to the intercept plus the slope times Y. It's just an equation of that line is all it is. So this right here is just an equation of the green line. And once again, we have simplified here by assuming we're dealing with an economy bigger than y sub 0. And so in that case, then, we can have it as a straight line. All right, let's see. Oh, I can hear my daughter talking outside about Ubering somewhere. I have a feeling I'm going to end up paying for that. All right. Well, in part because I told her I would. Now, let's see. Let me erase this. Maybe I need the water after all. Okay. Now check this out. Let's see. I think maybe the black one shows up well. We'll find out in a second. Y equals C plus I, and C equals A plus B times Y. Y equals C plus I is what we had in the first place, and C equals A plus B times Y is that new consumption function. Now fun with math. Let's see, I'll use a different color. Substitute A plus B times Y into the C, all right? Put that in the first equation in lieu of the C, that means instead of. It's one of them fancy words. So now we have all right, that's the equation now for GDP, for total spending. Total spending is now equal to, A plus B times Y, that's the same thing as C, plus investment right there. Okay, so now I know what you're thinking. Let us solve for Y. Oh, so we get all the Y's on one side and then solve for Y. Okay, so far we got y minus by is, that looks wrong. Oh no, that's right, okay. Is equal to a plus I. Now let's factor out the y. So now I'll get y times 1 minus b is equal to a plus I, and I'm going to have to erase at the top there and start working down from there. Okay, now you want to get the y all by itself on the left-hand side. Well, let's just see how we do that. Ta-da! Y equals 1 over 1 minus b in parentheses by itself times, in parentheses, a plus I. Okay, what that then says is that GDP is going to be equal to 1 over 1 minus b times the intercept of that consumption function curve plus however much investment is. Okay, fair enough mathematically, but what the heck does that mean? Well, let's see here. Let me first substitute in some values, and then let me tell you what that ends up showing. We should have like sponsorship for these lectures, like, you know, today's lecture on Monopoly brought to you by Microsoft. Now, let's see, I'm going to make up some numbers for B, A, and I. Alright, so just A equals 10, I equals 50. Again, A is kind of an imaginary number. It really doesn't exist in the macroeconomy, because if you remember, back up the thing about, I don't know, 7 or 8 minutes or so on the video, you'll see that was just like, well, let's assume that it's really the straight green line and not the curved, whatever color that line was, purple or black. So it doesn't have any specific economic relevance, but it's important to this equation. Now this does. This is total spending for investment in the macroeconomy. All right. Now B. B was the slope of the consumption function, and I didn't tell you this then, but that is the percentage of new income that people spend. So that if B is equal to 0.8, then for every new dollar you earn, you spend 80 cents. All right, for every new $10 you earn, you spend an extra $8. So if B is equal to 0.5, then people tend to spend 50% of any new income. All right, so that is called the marginal propensity to consume, which you can now totally forget if you want to. It's not important to this, but that's what Keynes called it, the marginal propensity to consume, or the marginal tendency to consume, or the tendency to consume new income. So let's make up 0.8 here. Oh, and by the way, it can't be any bigger than 1, because then that would mean that you spend all of new income, nor can it be any smaller than 0, which means you spend none of your new income. Okay, now let's see, 0.8. I'm an idiot. I meant to put the numbers in. Okay, so the first equation there, the first expression there is going to be 1 over 0.2, and 1 over 0.2 is 5. And the second one, and I'll do this one really, really slowly, 10 plus 50 is 60. So total GDP would be 300, right? Now, how are we figuring that? How is it that the only kind of the spending we've shown on here is the investment spending? It's 50. How come total spending would be 300? Well, we're not seeing the consumption, because remember, Y is really equal to C plus I. So if the investment is 50, then the consumption must have been 250, and I'll show that eventually, all right? But right now, let me explain instead what this is all about right there, that fraction. That's called the multiplier. I don't have any room. I'll write it over here. Or more technically, the income multiplier. And it is a function of the fact that when, let's say that firms increase spending by $10, all right? So they're gonna add one new cup holder at Amon Carter Stadium, which is probably more than $10. But let's say it's $10. All right, so this is an investment for TCU, right? And so that means that whoever put the cup holder in earned $10 worth of income. So when TCU spent $10 of investment, the company that put in the cup holder earned $10 of income. $10 in investment, $10 in income. But it doesn't end there, all right? Because then the people who receive that income at the company, they're going to go spend some of it. How much are they going to spend of it? Well, here they're going to spend 0.8. That's the percentage they're going to spend of it. So if it was $10, the initial increase in income, those people who put in the cup holder then go and spend $8 of the $10. And now income is increased by $18. And then the people who got the $8 spend $6.40 and on down like that. So what this is taking account of is the fact that that money is going to be spent over and over as people spend some percentage of their new income. Not all of it. If they spend all of it, then this process will go on forever. But this is the multiplier here is showing that, and let's use the example I have here, with a multiplier of 5, if TCU adds a new cup holder that costs $10, it eventually created $50 worth of income for the entire macro economy. All right, because the people who got the $10 went off and they had $10 worth of new income. They spend $8. Now there's $18 worth of new income in the macro economy as a whole. Then that person goes off and spends $6.40, which makes $24.40 worth of income in the macro economy, and on and on. And it will end up, if we keep doing that math, it will end up at $50. Right? What is it in real life? It's probably a lot closer to 2.5 or 3, something like that for the macro economy. Why do I use 5? Because it's the math's easy, right? Now, let's see, what was I going to tell you next? Okay, so, and this multiplier thing, by the way, there's some real world applications of that. For example, if I'm trying to get let's just make up a crazy example. Let's say that the Texas Rangers, who have a beautiful stadium already, let's say they wanted another one, for whatever reason. And I'm trying to convince the people of Arlington to pay for this stadium. Well, one of the things I'm going to do is I'm going to hire an economist to be like a hired gun for me, actually. But I want this economist to say, I know the stadium is going to cost X amount of money, but it's really going to create X times Y amount of total income for Arlington. And what's the times Y? It's the multiplier. That's exactly what it is. Those people who do those economic impact studies are using regional multipliers to figure out, how much they, now if they're not directly involved in the project, they're doing it to figure out, I wonder what the impact would be. If they are directly involved with the project, then of course they are finding any way possible to maximize that number in a way that seems reasonable, because that's what they got paid to do. So that's what the multiplier is. Oh, and it works in reverse too. When we lived in Indiana and my dad got transferred there, let's see, it must have been 1983. And the company my dad worked for, Peyton's, the local city government couldn't do enough for him. And the reason was because they had already lost a plant before that. A Corning glassware factory had shut down. And I don't know how big Bluffton is. Google it real quick. But let's say there were 300 people working at the Corning glassware factory. Well, that really costs more than 300 jobs, because this multiplier thing is not just income. As you can imagine, it's also directly related to employment as well. So let's make up a multiplier here. Let's say 3, all right? So if they lost 300 jobs at the Corning glass factory, they really lost 900 jobs in that city. So they're desperate to get a new big employer to then pump that number back up, so that they'll then have people going to the Dairy Queen and to the Kmart that was there and so forth. All right, so this is a real number that actually is important in the real world. Okay, where do I want to go next? I think I'm ready to go over the study question answer, because this is going to show how S ends up being equal to I. All right? Okay, so let me erase. Da-da-da-da-da. I was going to wear my favorite hat, my TCU Rose Bowl hat, but I cannot find it. I hope no one in the house has it. Now, let's see here. And I've been playing NCAA 2011 on the Xbox, and I want you to know that so far TCU is 3-0, and we've got some wonderful young men we're trying to recruit right now from around the nation. I just got 2 guys to commit. All right. Time check. It's been 22 minutes. All right. Now, here is the answer to the study question. So I'm going to have to end up, as you can see, because the board's really small, writing some of it out, then erasing, then writing some more out, and so on. It's set up just like the other one was. There's going to be, the first part's going to be, sort of the assumptions, the basic assumptions, behavioral assumptions, and then there's going to be the analysis after that. All right, so this is number 66. And let me read the question to you. In Keynes's model, what maintains the equality of investment and saving? ? Note that this argues that economies do not have to remain at full employment. Bracket, bunch of math plus explanation, bracket closed. All right, first thing. What does it say here, John? Restore the equality of. Okay, what that says is, and you remember from the last one, the very first sentence was changes in the interest rate, restore savings equal investment, sort of an opening statement to explain what's going on with it. This one has the opening statement of changes in income, restore the equality of savings and investment. So just kind of an opening statement saying, the question said, in Keynes's model, what maintains the equality? Well, changes in income do. Now you're going to explain how that works. And first, the behavioral assumptions. Hence writing behavioral assumptions. Let's say I'm going to have just three equations is what it's going to be. 3 equations. And oh no, that's right, yeah. And what else here? Oh yeah. Okay, so there's the 3 equations, and there's y is equal to 1 over 1 minus b times a plus I. That's the thing we derived just a second ago. There's the consumption function, and there is savings is equal to income minus consumption. And let me point this out real quick. In the other model, savings was a function of the interest rate. People would not bother saving were it not for the fact that they were offered interest. In this model, people save anyway. All right, people are worried about the future. They don't know what the future might bring. The future might bring something pleasant that I want to have some income ready for, or it might bring something unpleasant. So this here says that, how much do you save? Well, it really Savings is just what you have left over after you're done consuming from your income. It's just kind of a residual. Another one of the Keynes' things is that most consumption really isn't a choice. You've got to pay your house payments, you've got to pay your car payments, you've got to pay energy bills and so on. Most of it's not really optional. So as income goes up, how much you can choose to save goes up. Let's see. So now there's a specific reason why I wrote those three equations in that order. We're going to need them in that order. I'm going to start off with some sample numbers like I did a second ago, assuming a particular value for B and for A and so forth. And well, you'll see. It'll be very exciting. All right. Okay, so that's it for the behavioral assumptions. As you can see, I'm going to have to erase it. Okay, then the next thing says, I have the word analysis written up there. Because now you're done just setting up the model. It's going to be funny when this thing falls forward on my head and you'll have this on video. Anyway, that has analysis up there, and then we go through what happens. All right, and then here's this sort of opening statement. Whenever I changes, or investment changes, whenever investment changes, Y will change to compensate. And S will follow. Hang on. For example. All right, this is still all part of the answer. Okay? Wonderful health question material, by the way. Let's see. I'm going to go ahead and put 3 more things on this one before I erase it. Investment equals 50. Oh, it turns out to be the exact same numbers I assumed a minute ago. That's probably why I had them in my head. Let's just assume those are the right values for the macroeconomy. On the exam, it does not matter what numbers you make up there, the example will still work, all right? The only restriction here is that B has to be something between 0 and 1. But make it something that's easily, 1 over 1 minus B divisible, otherwise you'll give yourself a pain in the neck on the exam. But otherwise, the numbers themselves don't matter to the example. That's just what I made up right here for this one. Okay, ready, about to erase it. Okay. We normally use this for like on a family game night to keep track of scores. At Christmas, I came in 3rd in Trivial Pursuit for the first time in my life. Both of my daughters beat me. It was both a shaming moment and one where I was very proud. Okay. Aha! I've given you I equals 50, B equals 0.8, A equals 10. Now let's first plug all those numbers into the very first equation I had shown you under behavioral assumptions. And I'm going to assume, hey, we're all economists here. I'm going to assume that you knew how to take the 1 over 1 minus b and change that into 5. Because 1 over 1 minus b would have been 1 over 1 minus 0.8, which would be 1 over 0.2, which is 5. All right, so you don't have to, you can just, I do want to see this because I want you to make sure that you're thinking about that in studying this question, because that's something I could screw with on the health question, so I want you to focus in on it. As a matter of fact, in my notes here, I'm just glancing down, I didn't even have 5 times 10 plus 50. I just had 5 times 60 right away because the A plus I is going to be 60. All right, so then equal to 300. So how much is GDP right now? GDP is 300. Now, we want to figure out how much savings is. That's kind of a big deal because we want to see whether or not savings is the same size as investment, which is 50. And we don't know that yet. We haven't figured that out. It's not obvious at this point that that's true. So, in order to figure out how much savings is, though, we've got consumption right now. We've got income we need consumption, all right? Because remember, savings is equal to income minus consumption. So now we need to figure out consumption. Again, I didn't bother to write the general equation up there first. It was going to be C is equal to A plus B times Y. You can just jump right in with C is equal to 10 plus 0.8 times 300 because you already wrote C is equal to A plus B times Y earlier in the answer. Okay, and what's that going to be equal to? 250. Oh my gosh, this is fascinating. So, since income is equal to 300, and since consumption is 250, what must savings be? Oh my gosh. Savings turns out to be exactly the same size as investment. Even though we didn't set up a value for investment to start with, it's still, I'm sorry, we did that. Even though we didn't set up a value to begin with for savings, in the neoclassical one we did. We said, okay, let's say we start off where they're equal. Here we didn't say that. We just said, hey, let's just make up a number for investment, see what we get. I'll be darned. It turns out that savings, my apologies, I had set that for a half an hour for when to stop. But I'm going to keep on going. Because I did not realize that there was going to be a little clock right here that I could keep an eye on. Okay, so we had made up a value for investment, but not for savings. And so this is kind of significant that when we went through those three equations, we're like, oh, it turns out that savings is the exact same number. All right. Now, add this. Everything's great right now. Everything's at equilibrium when we're going to assume we're at full employment, just like we did in the neoclassical one. In the neoclassical one, we said let's start off with savings equal to investment, and let's assume that this is the level that's consistent with full employment. Then we had investment fall. But then the economy fixed itself. It re-injected spending by increasing investment as the interest rate fell, and increasing consumption, i.e. lowering savings as, did I say income fell? I meant to say interest rates. I'm going to do it again. That investment went down, and then me, the financial sector, I'm going to start lowering interest rates, which raises this kind of spending and raises this kind of spending. And I know this hand's going down, but that's because it's savings, right? Which means the consumption's going up. We're about to do the same thing. Not much left on this. Okay, so let's say that right now, where investment's 50 and savings is 50, we know that that's right. And let's just say we're at full employment. Ha-ha. Here's the trick. Now we're going to lower investment. We're going to do the exact same thing we did in the neoclassical one. We're going to lower investment, except now I have to have a specific value, so I'm going to go from 50 to 40. And let's see what happens. I kind of already know what happens, but let's just see anyway. All right, so we're coming up on the end of the answer now. We're going to have 1, 2, 3 equations and then a line that sort of sums things up. All right, so here's the critical problem. We have lowered investment to 40, and the question is savings going to somehow adjust to be equal to investment again, just like it did before with the neoclassical one? And in the neoclassical one, when investment went down, then interest rates adjusted, and they ended up equal again and significantly equal again at the same total level of economic activity, so we were still at full employment. That's not going to work out this time. We're going to do the same order of the three equations we did just a second ago. Y equals 1 over 1 minus b, c equals a plus b times y, and then s equals y minus c. So here we go. Again, well, I guess I do have it like that way. On this one now, 5 times 50 is, for those of you who aren't math majors, 250. So GDP has fallen to 250 at this point. Remember, investment fell by 10, but the multiplier is 5, so GDP fell by 50. And now let's figure out what consumption is. And to save you working that out in your head, it turns out to be 210. much is savings? Savings is going to be equal to total income minus total consumption. Oh my gosh, it turns out to be the exact same thing as investment. And it'll do that every time. Every time with this, the way this math works right here, every time you change I, S will change to end up being the exact same number. And let's see, let me get this final line here from the answer. Okay, and what that says is S equals I again, but at the cost of the level of economic activity. In other words, S is equal to I again, but GDP shrank. So this is what's happening, and that's the whole answer. That's everything now. So this is what Keynes is saying is happening. All right, we're going along, everything is great, savings equal to, I keep getting mixed up which hand it is. Savings is equal to investment, but then investment falls. All right. Well, in the neoclassical view, something happens that causes investment to recover and consumption to go up, so that they're equal again, and total spending hasn't fallen. Here's what happens instead. In Keynes, investment falls, and then GDP falls, and savings falls. All right. So everything sucks. Right? The economy comes to rest at less than full employment, and yes, savings is equal to investment, but by a different route. And I think that's it for this one. So I may do another video here with the next study question, but this closes up study question number 66. Thank you for tuning in. Please tell your friends, and don't forget to shop at, I guess I never did sell any advertising, so don't shop anywhere.